The Prime Minister and my Minister have both been very clear that our primary goal is innovation. Primary goal is making sure that our companies, our startups, our entrepreneurs are able to innovate and make sure that AI contributes on the development path. The opportunities exist in the real sectors of the economy. If you take agriculture, if you take manufacturing, if you take governance, if you take healthcare, education, in all these sectors, I think there are huge opportunities which exist, especially for a country like India, and that gives us an opportunity to really transform. India has the potential of becoming the application capital of the world. So how we apply AI in the real sectors of the economy is the crucial test. I think that is what will make a difference in terms of the economic transformation that any society can achieve. Today, not every small enterprise can afford to hire a consultant who can tell them things, who can sort of help them walk their way through improving. AI is a tool which they can use to actually achieve that. So we have to be much more strategic and figure out where is it that we can put down resources in order for a country like India to see this as transformative. I think 3 or 4 things are important. One, that we have to provide the infrastructure that AI needs, which is easily accessible. And what is the infrastructure that AI needs? You need access to compute, you need access to data, and you need access to models. All 3 are important. One thing we are looking at is those who are already in jobs who need to be upskilled, because otherwise there's a risk that they may lose their job because they're not keeping up with technology. So we run a program called Future Skills Prime along with NASSCOM, which is the industry body, so that people can be retrained, can be upskilled, and continue to be used. But the one place where we have currently a gap is we don't have chips of the kind that we want, both in terms of a company designing them and eventually a company building them in India. It will take a while. It's not something which you will get there in 1 year or 2 years. It will take a decade or 2 for us to get there. That is what the India Semiconductor Mission, especially India Semiconductor Mission 2.0, will focus on. So while we have not been there in the manufacturing space, we've been there in the design space for quite some time. The problem in the design is, while 20% of the human resources are of India and are deployed in India, all of them are doing work, or most of them are doing work for multinationals and large companies which do the designing here, but the IP belongs to a company somewhere else. So this is a reality today. Now what we are seeing is a spillover. People who work in these industries and you find that I'm developing a product for a Western company, why can't I do it for myself, for the country?
Hi everyone, welcome back to another episode of the Rocket Media. Today we are in Delhi for a very special conversation with Sri S. Krishnan ji, Secretary, Ministry of Electronics and IT to Government of India. Swagat sir, so glad to sit in front of you.
Thank you. Thank you for having me on this show.
Right. So we are living in a world where technology is changing faster than ever before, and we are here to talk about the Indian story, how India is adapting to this technology and AI era, how semiconductors and electronics are going to transform our economy, and what will it take for India to become a technological sovereign country and a true technology powerhouse. So are you ready?
Absolutely.
Great. So I was looking at your journey, and ChatGPT moment came in November 2022, and you joined MeitY in September 2023, right? So everyone was figuring out, okay, what is going in the world, and we didn't have any idea about the applications of AI, and you joined at that point of time. So what did it felt back then, and what were things in your mind?
See, I think I'm not a technologist by training, and therefore it was quite a challenge for somebody like me to be part of a ministry like MeitY. Coming into this job without a technology background was a bit of a challenge. But I think the important thing is you need to understand more than the technology itself. You need to understand the kind of impact that it can have and the difference it can make and the way that it can be adapted to truly make change in society and truly make change for a country like India. And I think that was the real learning that was there. And I think the realization that, we've gone through many phases in history of how technology has driven economic change. Globally, there have been agricultural revolutions, there's been an industrial revolution. So each time, it was technology which drove change. If you look at India's own history, there is, the discovery of iron and how you used iron made a difference in how you could clear the jungles in the Indo-Gangetic plain and settle this and make it one of the most densely populated areas in the world. And that's how, Indian civilization, as we know it today, arose. It was also technology linked. And as you move down in history, the Industrial Revolution, the first Industrial Revolution in the 18th and in the late 18th and the early 19th century, when mechanical power came to replace animal power and human power, and the impact that it had, and every subsequent edition of technology has moved the needle in a way. And now, one of the things which I think we realize as Indians is that what we have benefited from each of these phases of technology there have been undoubtedly benefits, but we have not benefited significantly. We have not transformed as a nation. In previous episodes where technological change took place. Clearly, in the 90s, when the information technology era took over, we have certainly benefited. There has been a substantial change in the way that we use this technology. We are acknowledged today in the world globally as an IT power. And the way that we have applied IT in order to solve various governance and other challenges, and the way that we are in a position to provide human resources for the rest of the world is something that is broadly admired and broadly recognized. But it's not been completely transformative for the country. And when the Prime Minister sets this vision of a Viksit Bharat by 2047, then you realize that these two moments are actually coming together. That this edition of technology with artificial intelligence, which many people call the Industrial Revolution 4.0 or 5.0, depending on which expert you talk to, gives you really the opportunity for a transformative change in an economy like India's. That, I think, was truly the opportunity, and how we actually achieve this will truly be where we stand.
Great. Sir, I think India missed the early industrialization part, and talking about then emerged as an IT powerhouse. So where India stands today, and how can we ensure that India don't miss this AI train? So like talking about the initiatives of the government, the IndiaAI Mission, and rest of the things. So if you can briefly talk about that.
You see, I think the important thing and the way that we have approached AI thus far, and we have to understand the way this is playing out globally. You have some private companies and private investors in the West, particularly in the United States, who are investing huge sums of money in building out both the infrastructure and creating the models for AI. In some ways, you recognize that the possibility of finding those kind of resources for investment is difficult in a country like India. At our stage of development, it's difficult to set apart resources on that scale for an AI transformation. So we have to be much more strategic and figure out where is it that we can put down resources in order for a country like India to see this as transformative. And we also have to recognize what our strengths are. Where do we have advantages? What are our strengths? The first and foremost is the human resources.
Right.
We are both a young country, and we also have fairly high talent in the STEM area. You're from an IIT, you will understand and recognize this. There are many youngsters like you in this space. The STEM talent in India is well recognized. The number of STEM graduates who come out every year is huge compared to what the global numbers are. And our ranking in the AI Vibrancy Index globally, which Stanford University puts out, is High primarily because of the quality of talent that we have. So that is one big plus. Second, we've gone through and become an IT powerhouse. So in that sense, in the IT services and generating revenue from that space, we are fairly big. So the ability that has its own sense of its own set of advantages. Third, we are not as dependent on white collar jobs as the Western economy is. So the negative impact of job losses in the cognitive sectors, because the one difference between this technology change, which AI is bringing about, and previous technology changes, is the fact that previous technology changes mostly replaced manual labor and repetitive work. This time, even cognitive work is at risk. So the kind of work that office workers do, white collar workers do, those kinds of jobs are the ones which are most at risk under an AI scenario. But then the opportunities exist in other sectors. The opportunities exist in the real sectors of the economy. If you take agriculture, if you take manufacturing, if you take governance, if you take healthcare, education, in all these sectors, I think there are huge opportunities which exist, especially for a country like India, to substantially enhance productivity without losing too many jobs, and in fact, adding a few jobs. And that gives us an opportunity to really transform. So how we apply AI in the real sectors of the economy is the crucial test. I think that is what will make a difference in terms of the economic transformation that any society can achieve. So, in manufacturing or in agriculture, how do you apply this technology in order to get better outcomes? Today, not every small enterprise can afford to hire a consultant who can tell them things, who can sort of help them walk their way through improving. AI is a tool which they can use to actually achieve that. Likewise, retrofitting AI for small manufacturing firms can make a significant difference in how more optimally to use their equipment, their existing resources to enhance productivity. All these are huge opportunities, and that's what we need to focus on and get done. We are trying to do that in MeitY. The other element is, of course, if you look at healthcare. I mean, in today's world, it is not anybody's case in India that we either have enough doctors or enough nurses to meet our requirements. If you can have tools at their disposal, diagnostic and other tools, which can actually make a difference as to how quickly they can diagnose and how much better they can diagnose, I think it makes a huge difference to the way healthcare itself would be administered and given, and it can make a huge difference to lives of people. And likewise, if you look at governance, I don't think it's anybody's case in India that that the quality of governance is what we would all aspire for it to be. Everyone, all of us have our own complaints. I've worked in the government now. This is my 37th year in government, and all of us recognize that we can do better, and there's a lot more that can be done. And citizens, people who are at the receiving end, have all of these grievances. So we can clearly improve quality of outcomes in that space. At the same time, we don't have as many. If you compare India's situation in terms of the number of officials or the number of people we have as teachers, the number of people we have policemen, the number of judges we have, or any of these categories which are cutting edge, people who deliver government services, I don't think we are way below international norms, way below what developed countries have. So clearly we can substantially raise the productivity of all these people, and we don't have resources to hire many more of these people. We can hire a few more, but we can't hire many, many more. So if you're able to raise that productivity and governance standards improve, that's clearly one way in which you can actually make sure that economic energy is unleashed. So all of these are important opportunities that we have. And for that, I think 3 or 4 things are important. One, that we have to provide the infrastructure that AI needs, which is easily accessible. And what is the infrastructure that AI needs? You need access to compute, you need access to data, and you need access to models. All three are important. So how do we provide this? That is what the AI mission looks at,
Right.
fundamentally. Make sure that we provide compute at an affordable price to innovators, to researchers, to small and medium enterprises, to entrepreneurs, and to students, whoever needs at an affordable price. We've been able today to provide access to GPUs at about 1/3 the price that it costs in other markets. So I think that's significant. I'm not saying we are able to provide enough. We need to provide more. But this is a strong start, and we need to push forward. And the model through which we are providing this, a voucher-based system, is something that many international agencies have felt is worth replicating for the rest of the world. So clearly that is one step. The other step is data. And through the AI course, we've been able to make available 11,000 plus data sets which people can use and access. And that for innovators becomes a very important tool. More needs to be done. There are many more data sets which need to be brought into this. This is a work in progress. Likewise, when it comes to models, we've sort of created the first Indian models. Sarvam was the first of those models to be launched. It has been rated fairly highly, even by NVIDIA in their annual technological festival, which is held soon after the AI mission. And the reason why we are doing our own models, experts have told us that maybe it's not essential for India to do all of our own models. But we felt that to capture the cultural and linguistic specificities of a country like India, it's important that we have some of our own models. And secondly, it's also important from the perspective of sovereign control. We can't afford the switches of many of these things to be elsewhere. We have to make sure that it's available within the country. So all these are factors which lead us to believe that we need to have some of these controls within India and manage it within the country, and that's something that we are doing. So these are three elements in terms of the infrastructure that we have. The other part of it is to make sure that we have the talent, make sure that enough people are trained. And so that is the other major vertical of the AI mission. So we are looking at 3 or 4 things in that space. One thing we are looking at is those who are already in jobs who need to be upskilled, because otherwise there's a risk that they may lose their jobs because they're not keeping up with technology. So we run a program called Future Skills Prime along with NASSCOM, which is the industry body, so that people can be retrained, can be upskilled, and continue to be used. We have spoken to the Ministry of Education to make sure that both at the school level and at the university level, AI is taught across all disciplines. Because I think today, what is important that in every domain, AI as a horizontal technology can be used. So everyone needs to be aware. You're probably, I don't know what scientist you are, you're probably a computer scientist.
My stream was economics.
You're an economist. Okay, but, most... it's not something which needs to be taught only to computer
but we used to code mostly.
No, that's true. So, but it's not just them. I think everyone needs to learn how this works and how AI works and how it can work better for them, and have that exposure, because it's going to be used everywhere. I say even an art historian needs to know this. Students in linguistics need to know this. So everybody needs to learn this. So that, I think, is the second vertical we are looking at. And of course, the third vertical is those who are already in government jobs. So we have a big program running through Karmayogi Bharat, which is our platform for training government servants. So all of them are running courses. It's one of the most popular courses there. So this is something which needs to be a constant push. MeitY alone doesn't do this. We work with other ministries. We work with the Ministry of Education. We work with the Ministry of Skill Development. We work with state governments. So all of them need to work to make sure that the skilling part of it happens. And then, of course, we support innovation. So what needs to happen in innovation is something which is important. Now, above all this is India has the potential of becoming the application capital of the world. Because of our strength in IT/ITES, I mentioned earlier that IT/ITES is an important area that we are concerned with. So if you're good in IT/ITES, then what do you do with all these programmers, coders, software engineers who are in that space? Today, we need to retrain them, and that's where the upskilling part comes. These are the people who need to go out, because it's one thing to say adopt AI and adopt it in all these sectors, but it's another thing as to who will actually, develop some applications, develop some solutions, and see that they actually get deployed. That work still needs to be done. You may not have to code and program, but you have to understand the domain, develop the application, and go and deploy it. And that's where all of these, the strength that we have, they are the people who will have to develop these applications and do it. Likewise, the startups. So these are the two, brute workforces that we have who can actually serve the entire AI economy, both in India and overseas. And in that sense, I think the opportunities for creating more jobs is certainly there. That is what the study which NITI-Aayog had also done in this space, that's what it reveals. So this is another important area of what we need to do, applications. And our focus has been substantially on the kind of applications we can develop. That was an important part of the AI mission. There's substantial funding for that. And equally, in the AI summit as well, there was a lot of focus on the applications. Close to 1,000 startups were present who demonstrated different kinds of applications they had developed. You had a number of other private companies who were out there and demonstrating what they had developed and which can be adapted. And many of them got very, very interesting buy-ins from a range of international buyers. This afternoon, I was at a lunch which was hosted by the Prime Minister for the President of Cyprus. And it was very interesting to find, and that particular startup was incubated at IIT Kanpur. And they are a startup which works on AI and cybersecurity. And they were spotted by the Cyprus delegation in the AI summit, demonstrating their capabilities, and they were invited to visit the Cyprus, and now they are building AI applications and AI stack for Cyprus from between IIT Kanpur and IIT Madras at Chennai. This company, the name slips me right now, they are doing this work. So it's a remarkable story. It's what Indian companies can do, Indian startups can do, and how the India AI Mission and the India AI Summit became truly an opportunity for a company to showcase itself and actually get there. So I think it's quite remarkable, and there are a number of other cases like this that I've heard where companies have been able to deliver. So I think it's a true reflection on how the application layer has been working. So in each of these, it's important. And the last and very critical thing is safety. That AI needs to be safe. There needs to be some safety-related issues and governance-related issues which need to be addressed. And in the present context, when everyone is talking about Mythos and everything else, safety and regulation is becoming that much more important. Globally, countries are realizing why this is important and why you have to have some guardrails and some regulation on how this is done. And that is an area we've been constantly exploring. Our belief on the governance side is that existing legislation, existing rules cover many of the possible harms that AI can cause. And we have been using those rules to actually look at ways in which deepfakes could cause harm, the way that they get used in social media could cause harm, the virality of all of that. Those are issues we have tried to address already through existing framework of rules and laws. But eventually, if we need to sort of step forward and take care of some of these issues a little better, we'll have to be prepared to do that too. But the Prime Minister and my minister have both been very clear that our primary goal is innovation. Primary goal is making sure that our companies, our startups, our entrepreneurs are able to innovate and make sure that AI contributes on the development path. And when there is a need to regulate and when we need to step in, we are ready to regulate.
Great. I think you have given me whole general idea of AI and everything that we are doing as a country. And first of all, kudos to you that literally we got some serious outcomes of the AI Impact Summit. That a startup got this kind of opportunity. So I think that is that is very appreciable. Like, we got that kind of outcome. Now we'll try to go deep into these topics, like talking about one by one. What is the role of government, like, in creating that battleground for India, like, to grow as a AI country. And talking about, first of all, infrastructure, we need GPUs, we need data, we need our own models and everything. So I think AI mission, like, we deployed 38,000 GPUs, and now we are tendering for another 20 to 25,000 GPUs. So that is the supply side. So talking about the demand side, so what is the demand, and where are Indian startups up to in this
The demand is
race?
clearly growing.
Okay.
Demand is clearly growing, and which is a very hopeful thing. And if we are able to provide that within the country, it's important. It's also equally important that those large investments need to take place in the country so that the requirements are met. Which is one reason why I think in the latest budget we've permitted certain clarifications in the tax space, which will sort of speed up investment in the data center space and also in the AI compute provision space. International companies would be able to set up large facilities here, and these would work for the rest of the world as well. While they work for the rest of the world, a certain portion of it will work for the Indian market. So that will work to our advantage. In addition, other companies are also, we are providing clarity in the way that we procure AI compute to make sure that more companies are able to make investments in this space in the coming days. And they are much more nimble and faster at doing that, and which is why we believe that we can proceed on that basis. You'd have also read in the papers recently or seen in the media, we had a MOU signed between CDAC and G42 of UAE. And that is basically to set up a fairly large wafer scale facility for inferencing in the country. And that is another part of the infrastructure which is growing. But we are not satisfied only with infrastructure growing as part of importing and everything coming together. We also realize that it's important to grow our own stack. Everyone talks about those 5 layers of the AI stack,
right?
Energy, and you're familiar with all 5. So we need to have a significantly larger presence in, say, the kind of chips that we will have. Energy, yes, we are already developed. Each of these 5 stacks, we have our own developments in the way that they are going. But the one place where we have currently a gap is we don't have chips of the kind that we want, both in terms of a company designing them and eventually a company building them in India. That is what the India Semiconductor Mission, especially India Semiconductor Mission 2.0, will focus on.
Right.
To make sure that we are able to support enough Indian companies and Indian entrepreneurs to actually both design chips and to sort of take that forward. So that is one area of work which will be an important part of what we want to do under ISM 2.0. And that, to my mind, is significant and will be an important way in which, in the future, we actually secure our space and we create a way in which we are reasonably self-reliant in this area. I think that's an important way forward. Second thing, we are already able to assemble and build high-power compute and also AI-related compute servers in India itself. There are Indian companies which are now able to put together servers of that nature. They've become ODMs to manufacture that, and they're doing it. So that, again, is a good development. So there could soon be entire server farms, entire data centers which have Indian servers in them. So that is another possibility which we are looking at. So each of these is an important element of what we are doing. Likewise, if you're looking at high bandwidth memory, under ISM 2.0, we'll have to see how much of that we can attract. Micron, which is sort of putting together chips in Sanand right now, will be sort of working in this area of memory. So we'll have to see how that development moves forward to make sure that that requirement is also met. So there'll be a range of requirements, equipment, the entire technology stack, which we need to have some degree of. I'm not saying that 100% we'll build in India, but we'll have the capability of doing it when we need it, so that we don't become overly reliant on any one particular source of supply. We have a diversified source of supply for that. So this is broadly the kind of strategy that we are looking at in this space in the days to come.
Right. And when you talk about this is a very long-term plan, India Semiconductor Mission 2.0, that is, I think, a decade-long plan. But talking about short-term, like talking about Indian startups and building our own LLMs and hosting it in India, like particularly looking at recent that Mythos thing and everything. So where are we in terms of that?
Now, as I told you
Right.
earlier, that we have commissioned India's own models. 15 and now more will be commissioned. It's a combination of large language models, basically foundation models, combination of large models and small models. Small models are more oriented towards a particular sector, and Sarvan was the first of them,
Right.
as I mentioned. Bharat from IIT Bombay they are also building out. So both of these are going fairly well and fairly quickly, and we are working with their teams to make sure that our work goes forward. And that is a capacity we are building. I'm not saying that they are the leading frontier models yet, but unless we have the capability of building some of these models, we won't get to the frontier.
Yeah, right. Even India is such a diverse country with so many languages and so many kinds of people. So, I think the LLMs and the models that the foreign giants have, I think they are not cannot be deployed in India for masses. So we definitely need our own multilingual models and those.
That is exactly what both Sarvam and Bharat are doing. That's precisely why we are building our own models, because it has to address the diversity, both language and culture, in a country like India.
Right. And sir, as you were mentioning about that semiconductor plants and semiconductor mission, so I was just looking one day at the India-China trade deficit, and still what we mostly import is electronic components and those stuffs. So with this mission, what kind of changes we can expect in our economy and trade deficit and rest of the things?
I think there's a slight, and let me sort of split that question in two parts.
Okay.
Semiconductors, most of our import of semiconductors are not necessarily from China. China also imports semiconductors mostly from, Taiwan, Korea, and places like that. The biggest import for us are electronic components other than semiconductors from China. So we have launched a scheme called the Electronic Component Manufacturing Scheme.
ECMS scheme.
ECMS, which has been a fairly successful, very good response. We've cleared a large number of applications, nearly 70 applications already, 69 applications or so, and the process is ongoing. And their companies have started manufacturing various components in the country. You must understand that today on the electronics side, about 45% of electronics consumed globally and in India are basically mobile phones.
Right.
And that is the biggest, largest single item. So I think it's important to recognize that in, say, 10 years ago, no, 2014-15, we were importing about 75% of the mobile phones that were sold in India. Today, we actually export mobile phones. So things have changed. But one factor which we are well aware of is that the value addition in mobile phones is currently at about 18 to 20%. It is not very high. We want to at least double this value addition, take it to 35 to 40% from the present 18 to 20%, and we are moving in that direction. That is the objective of the ECMS scheme, to make sure that in the value addition in India increases in electronic items. One issue with electronic items which we should be clear about is that these form part of a global value chain. Nowhere, not even in China, is the entire manufacture taking place right there. Any of these phones, if you look at it, they would have crossed the border at least 70 times before the phone is finally manufactured. So it sort of goes back and forth and things. So let's be clear that we have to make sure that we are in a position to meet this requirement of electronics. The increase of the value addition. I think it's important. It's also important to do this because we should not the assembly of a lot of these devices happens in India. And it's a good thing because that's the most labor intensive part of the entire manufacturing process. The largest factories today in India, which employ about 50, 60,000 workers, are factories which basically assemble electronic items. So for a country like India, those jobs are very, very important. So we should not scoff at what is happening in terms of the assembly. But what we need to make sure is that in addition to assembly, we also increase value addition so that somebody doesn't tomorrow try to, what happens with assembly is the investment in equipment is very low. So once the equipment is depreciated in about 8 to 9 years, it's very possible for you to just go and establish a new factory or a new facility in some other part of the world and continue where the labor is cheaper. So we can't rely only on labor arbitrage to make sure that our position is secure in this space. That is why it's important to manufacture electronic components. And it's important to manufacture electronic components which are of high quality because you make it not only for yourself, because it's a global value chain, you export them also. And that way you're assured that you're making it of sufficient quality that anybody in the world will also buy it because you made something which is good. And you're not sort of subsidizing something which is second rate. You're at the cutting edge in terms of technology. Interesting thing which few people realize is that last year we actually exported $2.5 billion worth of electronic components to China. So from virtually nothing. So we are moving up that value chain. You mentioned about the huge
trade deficit.
Trade deficit. There is a huge trade deficit. There's been a small but significant movement in the other direction, and hopefully that should grow in the days to come. The other point that you made is about semiconductors.
Right.
And semiconductors, again, that industry comes from different parts of the world. Today, we import practically all our semiconductors. Only now, February 28th, the Prime Minister inaugurated the Sanand plant of Micron. March 31st, he inaugurated the Keynes plant. There'll be at least 2 or 3 more plants which will get inaugurated this year during 2026. So we've made a significant forward movement in terms of what is happening in the semiconductor space, in terms of who's kind of moving forward and how the work is going forward there. So I think, but let's be clear. Currently our demand for semiconductors is about $40 billion. And it's likely to grow to about $100 billion by 2030. So we've cleared and approved 12 projects under the India Semiconductor Mission Phase 1. All these 12 projects together will probably manufacture about 10 to 12% of our total demand of semiconductors in the country. We are still a long way from completely manufacturing. We'll continue to import. Even after we sort of set up more facilities, there will be certain types of semiconductors which we will continue to import. It may not make sense to invest in all. But at least we'll be an important part of many of the key areas of the semiconductor domain. And we'll also have a capacity to export some of them. So it'll be a give and take. Which means there's a lot more which needs to be done in that journey too.
And sir, many people also criticize India is entering this semiconductor space with mature nodes 28 nm or 40 nm chips, and while world is running toward cutting edge 2-3 nm chips. So is this India's strategy to first manufacture this kind of chips and then?
See, I think there are 2 or 3 things which are important. I think fun. So there are 2 or 3 things which are important. One which is important is to realize that whatever it is across the world, establishing a new semiconductor facility has to be subsidized by the government. This is true whether it is the United States, whether it's Europe, whether it's Japan, whether it's Taiwan, whether it's Korea, whether it is...
It's very investment-heavy industry.
China, it's investment-heavy, it's very cyclical. Nobody can bear it because it's a foundational industry. Governments across the world have always subsidized it. That's how we stepped into this. About 20 years ago, I used to work in the finance ministry at that time. Intel first came in to establish a facility here, and they were looking at various things. And conversations were almost at an end. And suddenly we had an issue saying that they said, look, we want a grant of $100 million. And we didn't have a policy in place in the government of India to give a grant of that nature. State governments had some policies in terms of, they could give some subsidies, etc. We never had that sort of a program. It's only after that that even thinking started around it. Therefore, and that is when the India Semiconductor Mission 1.0 was finally formulated in 2021 and things to move forward. Now, if you look at that mission and if you see, the way that is gone forward and what has been done there, I think it's important to recognize that in the semiconductor mission, we for the first time recognized payment of subsidies at that scale. People criticized $10 billion. You could have put it on 10 other things. You could have done a variety of things. We have to recognize that we have to start somewhere. And you're not in that space of manufacturing. It is very advanced manufacturing. You have to begin somewhere in order to start. So it is better to start in a safe and mature node where you can learn and you can build. Therefore, that is one reason that, technologically it is easier to address that. The second reason is that as you move down to the leading nodes and as it shrinks from 28 nanometers to 14 to 7 to 5, 4 and so on, the rise in the cost is exponential and the subsidy you would require also is substantially higher. Ours, 76,000 crores. At that point, it was estimated at about $10 billion. Now, you look at most parts of the West, people are putting down $50 billion, $60 billion. Our fisc can afford a particular sum. We can't sort of be over-ambitious on a risky node. And it's ultimately taxpayers' money. It's public money. Therefore, we have to sort of balance the advantages and the risks. And the last thing which you need to be conscious about is, while they could be leading nodes and while they could be used in certain kinds of technology like mobile phones, the legacy nodes, the mature nodes, continue to be used all the time. If you're looking at a spacecraft or if you're looking at a rocket which goes to space or a missile or any of those, they will continue to use 180 nanometer nodes. They're not asking us to, shrink it. If you're looking at the automobile sector, they are happy to use between 60 and 110, 135, 140 nanometer nodes. So they are not asking you to shrink it because for their utilization, this is good enough and this works. So from that perspective, I think the mature nodes continue to have adequate demand. So we wanted to make sure that, one, you had safe technology, you had a technology which had adequate demand, and you made sure that you were not getting into a space where the subsidy requirements were too high. So our point is that you first establish your capability to manufacture the advanced manufacturing techniques, which we have not had in this country so far. You first do it in these nodes, and then you move forward into the leading nodes as a part of organic research. So I think rather than being criticized for this, I think people should recognize it's a well-considered, prudent decision given our circumstances. In these circumstances, this is the best that India could do, and I think to establish ourselves in that position and move forward. For 60 years, you've not had a semiconductor plant. When you finally get one, you then say, ye theek nahi hai, wo theek nahi hai. I think that is really not fair.
Right. So for manufacturing, it's good. But talking about that cutting edge research and technologies, so are researchers or are we collaborating with any academia for developing just like, for research part? Are we doing something cutting edge on ground?
Yeah, I think that is something which is a very interesting question. You see, in the semiconductor design space, while we have not been there in the manufacturing space, we've been there in the design space for quite some time. 20% of the semiconductor design manpower in the world is in India. The first GCC, which was set up as early as 1984, was by Texas Instruments in Bangalore, which started designing semiconductor chips. So we've had a fairly long track record in the designs part of it. The problem in the design is, while 20% of the human resources are of India and are deployed in India, all of them are doing work, or most of them are doing work for multinationals and large companies which do the designing here, but the IP belongs to a company somewhere else. So this is a reality today. No, I'm not saying it's a bad thing because, these are higher quality jobs. This has trained so many people who have learned how to do this. So all these are opportunities. So there's clearly a significant benefit to the Indian economy and Indian ecosystem. Now what we are seeing is a spillover. People who worked in these industries, and you find that I'm developing something, a product for a Western company. Why can't I do it for myself, for the country, with the IP? So now we have people who are coming up and saying that, we have spun off from there, we have set up this small startup, and we want to sort of do this. Under the design linked incentive scheme, that is what we have supported. And I think one of the remarkable things is the way we have supported education in VLSI design and going forward. The Chips to Startup program and the program under which we have provided access to EDA tools is one of the most remarkable ones. We started with the objective of doing it in 100 engineering colleges and universities. We are now supporting close to 400. More than 80,000 students have learned these skills. The number of man hours for which these tools have been used is immense. So clearly we have seeded that ecosystem. VLSI design now is a very, very sought after course in many engineering colleges across, and not just in the IITs, but even in tier 2, tier 3 colleges. MeitY has invested over the last 15, 20 years about very substantial sums of money in setting up academic research fabs, first in Indian Institute of Science and IIT Bombay, and later in 5 other IITs, IIT Madras, IIT Delhi, IIT Guwahati, IIT Kharagpur, and IIT Kanpur. So we have set up these research level fab facilities, academic fab facilities in these places, which are being used extensively. And we've also ensured that these are called nanoscience centers. And we've also insisted that these need to be used as hub and spoke model with a number of colleges, engineering colleges and others having access to this facility. That's been a fairly remarkable success in terms of how we have built a trained human resource in this space. We are also collaborating with a number of other countries, with the Netherlands, with Singapore, with Taiwan, with Malaysia and others, to train people in this space. We exchange human resources in this VLSI design space so that our engineers get better and better at doing this. So I think that has been a big success, and you will see that we will try to really push further with the development of this talent as part of the ISM 2.0 program.
Great. And sir, talking about all these programs, so any real outcomes that we have received from all these programs that have been deployed? And
see, in the DLI program, we supported 24 startups to develop chips of various kinds. 15 of those startups have received VC funding from multiple sources, so which means they have been quite successful. Some of them are now selling their chips to drone companies, to CCTV companies, and to others. So they've been able to pick up the market as well. So it's been fairly successful.
So are you very confident that India will not just enter, but could be on the top in these semiconductors and these things in future?
It will take a while. It's not something which you will get there in 1 year or 2 years. It will take a decade or two for us to get there. But I think we are now well on our way.
And especially after this recent Tata and ASML deal. So if you can briefly talk about that too.
See, I think ASML, as you know, is the leading company which makes lithographic equipment in the world. So no fab can be built without ASML equipment. And so I think it's a matter of great pride that ASML is entering into a supply contract, because this will be the first time that they are actually entering India. And what they do once they enter a particular market is to sort of then put down roots and look for other opportunities and so on. So there'll be further developments. And we hope that eventually we'll also have a possibility of other companies actually supplying into ASML to make their final equipment. So that's a big opportunity for technology development for other companies to manufacture for them. Manufacturing the semiconductor chip itself is a complex process and
Right.
requires high precision equipment. Now imagine how much more complex the process of manufacturing the equipment would be, which can produce those kind of outcomes. And so that is the opportunity which lies, and I think that's a very exciting proposition.
So this equipment, like, we are importing those equipments, but are we also doing something like, in a long term, if we can be independent or self-reliant in that too?
Well, I mean, again, I wouldn't say that we'll make it all ourselves.
Yes.
It's difficult to do that in a globally connected world, but I think it's important to realize that many leading semiconductor equipment manufacturers are already in India doing some of their research and other work. For instance, Applied Materials, Lam Research, all of them have offices in India where they do fairly extensive research, and they've been expanding. We expect that under the India Semiconductor Mission Phase 2, there will be more and more of these companies which will start establishing facilities in India to actually put together their equipment. And like I said, it's like making a plane, because what they do is assemble components from a number of makers across the world and put it together. It gives an opportunity for Indian companies, especially MSMEs, because they're the ones who manufacture all of these components mostly, for them to make for these large semiconductor equipment manufacturing companies. And I think that's a huge opportunity, which we will be focusing on in the India Semiconductor Mission Phase 2.
So can you please speak more on this Semiconductor Mission 2.0, because we get this constant request, like if you can bring someone to speak on this, very broadly.
See, the point is that there are only some things that I can say and some things I can't say, because it's not yet been approved by the cabinet. But we are in the process of preparing the scheme. It has been announced in the budget for this year, saying that we will come out with the ISM 2.0. So we are putting together this ISM 2.0. It builds on what we have done during ISM 1.0 in terms of, I mentioned that 12 schemes have been approved. We focused on certain areas there. Then we'll shift focus slightly in ISM 2.0 in terms of refine our focus and make it sharper on some of the other technology areas where we believe that more investments need to be brought into the country. So that is one part of it. The second part of it is that we will follow an ecosystem approach in terms of making sure that, in the phase 1 of the program, we supported basically fabs and OSATs to be established. Now we will support a wider cross-section. We'll support people who build equipment. We'll support people who make the materials, who make all the chemicals, the gases for this. We will support companies which do the testing and prepare testing equipment for semiconductors. So that entire ecosystem will get support under ISM 2.0 in the way that we have planned it. So this is the second major thing. The third major thing is that there will be also a fairly sharp push in the direction of research. Because as I told you, if we are going to get into more advanced nodes and if we are going to get into certain other areas, we need to build research capacity. Globally, when we have visited various countries, I've personally been to the A-Star and other facilities in Singapore. I've been to IMEC in Belgium. I've been to Albany in upstate New York, where IBM, along with the state, New York State, they put together a big research facility. In all of these, in addition, today we have done academic fabs in selected IITs and leading institutions. What we see in these places is there are two other kinds of facilities which we need to create. One facility is translating this sort of academic level research to the next level of research. That happens in a industry academia joint facility, joint research facility. Those are the kind of facilities which we will need to create in India as well in the days to come. The other element is we need to sort of build fabs, not fabs, but we need to build training facilities to train workers.
Right.
We have done some of that. See, someone who's actually going to work with front end or back end in one of these facilities. So how are they trained? How will they actually work with the equipment? So that is an important part of what we intend to do in the days to come. So I think these are all huge opportunities that we see, and where we think significant way forward is possible.
And so, like talking about this whole industry, when we look at AI, there are a lot of companies contributing to AI. But the common perception about this semiconductor thing is like, you need heavy investments and heavy machineries and all. So how can like, a small startup or a people can contribute to this on their own level?
In the semiconductor space, the biggest contribution comes in design.
Right. Okay.
And that is what we support. So startups and others are disruptive in terms of designing products. Some of the big companies, semiconductor companies in the world today, are actually fabulous companies, starting with the most valuable company, NVIDIA. They don't make it themselves. They only design, and they get others to make it for them. So I think clearly in the design space is where we see in the semiconductor industry the participation of startups and small enterprises.
Great. And so, like, if someone 20-year-old watching this, or maybe from a tier two city, like, and who want to be part of India's tech future. So, what is the honest thing, like, you would like to tell them where the real opportunity is and what they can do to contribute?
I mean, there are a range of options in the technology space. I think it's very important to go into, I mean, there are 3 or 4 things which I think are very important. One area which is very important is deep research and deep science, which will actually result in outcomes. We have to sort of have that ability to design and bring out actual products. I mean, so that depth of research is needed. Second is design is very important. We don't design many products. We are not currently what is called a product nation. You have to design a product which will, meet certain aspirations. Those investments have to be made. Sometimes those investments cannot be made by a small startup, but it has to be done by a larger company. But to work in the design space will be a big opportunity for many who need to work in that space. So that is an important opportunity. Likewise, I would say that they should not shy away from working with their hands. I think in India, we have tended to think that working with your hands is something which is not so prestigious. White collar jobs, I'm wearing a white shirt today, but white collar jobs is what most people prefer. They want to be in jobs like mine. I'm not saying that you shouldn't aspire to be, but I think there's a lot of contribution you can make and there is nothing at all wrong with working with your hands. I think many countries in the West have advanced by respecting people who work with their hands. And I think that's an important element. So that's the kind of work also that they should be prepared to go. And the last area is, where can technology be applied to truly make a difference to people's lives? And that is applications, AI-based applications. I mean, there are people who have done remarkable things. I know a startup in Kerala which is built, it's a small robot called Bandicoot, which cleans sewers. So you don't have to allow people to actually get into sewers anymore. And there are so many deaths which happen with people, and why would, it's one of the most difficult and unhygienic jobs to be doing. So you can eliminate human labor from those kind of areas. So there are, applications of technology which make real difference to the lives of people. And I think startups have a wonderful opportunity to contribute there. So I think in the technology space, there are so many things they can do, and it should excite them, and they should really get into it.
And so, like, looking ahead at like 2030, and as you mentioned, 2047, Viksit Bharat. So, like talking about electronics, IT, and AI, what is your ambition? Like, where we should be next 10, 15 years?
No, I think it needs to be the country's ambition. I'm only a cog in this. I think we need to systematically build capacities to actually manufacture more in this country and manufacture in spaces of things which people in this country need at affordable costs. I mean, even if you're looking at a mobile phone, an affordable smartphone which people can use, that would be something which would be truly valuable, which we can manufacture and supply to them. Likewise, various other products which people will use and people will need can be manufactured for them in the country, which then means that they find the jobs, they sort of find meaningful employment, they find meaningful things to do. So I think both these need to really go hand in hand. And the emphasis needs to be on this. And the emphasis also needs to be that in the AI space, as we sort of move forward, we have to be clear and we have to be sure that, it's these, creating these solutions and applications which will make the difference. That is important. And third is that I think we should absolutely not ignore domain knowledge. Even in an AI world, the domain knowledge is what becomes very, very crucial. You need to know whether what AI is telling you is right or wrong.
Right.
And unless you know that, it can be quite tragic. The consequences can be tragic. So I think while AI can substitute for many other things, it can't substitute for an understanding of the real world and domain knowledge about a particular space. So I think you will find that in education and in all other areas, emphasis on domain knowledge will be important, and that's something that people should aspire to.
Great. Thank you so much, sir, for your time and for the insights. So much to learn from you. And thank you so much.
Thank you.